Hi everybody, I'm Professor Rad, and today we're going to talk about measures of dispersion, specifically the range. So let's start out by defining what a measure of dispersion is. So a measure of dispersion measures how spread out the data values are, so how dispersed they are. We're going to look at the easiest one in this video. In the next video, we're going to talk about more complicated type of measure of dispersion. So the first one, if I want to see how spread out the data are, I could just examine, well, what's the biggest and what's the smallest, and how far apart are they? And that will give me a sense of how far the data ranged. So we're going to call this measure the range. So the range of a data set is the difference between the largest value and the smallest value. Now, we had a measure of center called the mid-range. So I'm going to put kind of like a little caution here. The mid-range is a measure of center. And the formula for that was max plus min, and then divided that by 2. You don't want to confuse the mid-range with the range. So the range takes the maximum value and subtracts the minimum. Notice in the formula for the mid-range that you're adding the 2 and then dividing. So they use similar components of the data set. They both use the max and the min, but the formulas are different and what they measure is different. So the mid-range measures kind of the midpoint between those two. The range measures how far apart they are. So a common mistake that I often see with formulas is after we learn the range, a mistake is to put a subtraction here in the mid-range formula. So you don't want to do that. You want to make sure you give yourself a note so that you don't make a mistake with the formula. And similarly, there's no dividing by 2 for the range. It's just subtracting those two values. All right, so let's go ahead and look at a couple of data sets and compare them. So for data set A, we want to find the range. So it looks like the data is in order already for us. So we can just go ahead and subtract 102 minus 22. And that's going to give us 80. So I'm going to put 80 degrees Fahrenheit here. Make sure to label your answers. For data set B, we have, similarly, the values are already presented to us in order. So the first one is 60 and the maximum is 68. So I'm going to do 68 minus 60. And that will give us 8. So we have 8 degrees Fahrenheit. Now, if I look at the median of both of these data sets, just as a comparison point, the median of data set A is 63 degrees. For this one, if I kind of go towards the middle here, it's also going to be 63 degrees. So these two data sets could be said to have the same average. They have a common measure of center, 63 degrees, but their ranges are extremely different. So this range of 80 degrees means that, say, over the course of a month, the temperature ranged 80 degrees, right? So that was the difference between the highest and lowest, a very volatile place to live. Whereas here, if we had 8 degrees over the course of a month, that would mean, the biggest difference in temperature we ever saw was 8 degrees. So very consistent, moderate climate. So I have a question here that says, suppose an additional value of 32 degrees is added to dataset B. How is that going to change the range? So 32 in that case would become the new minimum. So we would do 68 minus 32, which is going to give us 36. So if I throw in, say, an outlier, that had a huge impact on the range. So this means, is the range resistant to outliers? No. for the same reason that the mid-range wasn't resistant to outliers. So the mid-range and the range rely exclusively on those extreme values. So if you have one of your extreme values being super extreme, so much so that it lives away from the rest of the data set, that's going to have a big impact on the range. So we're going to want a better way of approximating the measure of dispersion. So we're going to talk about that in our next video when we talk about standard deviation. So I'm looking forward to seeing you then. In the meantime, have an excellent day. Bye for now, everyone.